Hi, welcome to my YouTube channel. I'm Cheryl and I'm gonna talk about what is graph and planar graphs. Graph is a mathematical representation of a network and it describes the relationship between lines and points. A graph consists of some points and lines between them. The length of the lines and position of the points do not matter. A graph can be defined as a pictorial representation or a diagram that represents data or values in an organized manner. In mathematics, and more specifically in graph theory, a graph is a structure amounting to a set of objects in which some pairs of the objects are in some sense related. The objects correspond to mathematical abstractions called vertices, also called nodes or points, and each of the related pairs of vertices is called an edge. Now, for example, we can represent the data given below, the type and number of school supplies used by students in a class, on a graph. We begin by counting each supply and representing the data in particular colors in a systematic order in a table. Now my friend Sakura and Yena will explain about planar graph.
Hello, I'm Sakura, Cheryl's friend. Now I'm gonna talk about planar graph. When a connected graph can be drawn without any edges crossing, it is called planar. When a planar graph is drawn in this way, it divides the plane into regions, called faces. When is it possible to draw a graph so that none of the edges cross? We can say the graph is planar, since you can draw it on the plane. Notice that the definition of planar includes the phrase "it is possible to." This means that even if a graph does not look like it is planar, it still might be. Perhaps you can redraw it in a way in which no edges cross. For example, this is a planar graph. That is because we can redraw it like this. The graphs are the same, so if one is planar, the other must be too. However, the original drawing of the graph was not a planar representation of the graph. When a planar graph is drawn without edges crossing, the edges and vertices of the graph divide the plane into regions. We will call each region a face. The graph above has 3 faces. Include the outside region as a face. The number of faces does not change no matter how you draw the graph, as long as you do so without the edges crossing, so it makes sense to ascribe the number of faces as a property of the planar graph. For your information, you can only count faces when the graph is drawn in a planar way. For example, consider these 2 representations of the same graph. If you try to count faces using the graph on the left, you might say there are 5 faces including the outside. But drawing the graph with a planar representation shows that in fact there are only 4 faces. Okay. Next is gonna explained by my friends Yena. Hi, I'm Yena and I will continue the explanation from Sakura. Why is Euler's formula true? One way to convince yourself of its validity is to draw a planar graph step by step. Start with the graph P2. Any connected graph, besides just a single isolated vertex, must contain this subgraph. Now build up to your graph by adding edges and vertices. Each step will consist of either adding a new vertex connected by a new edge to part of your graph, so creating a new spike, or by connecting 2 vertices already in the graph with a new edge, completing a circuit. What do these moves do? When adding the spike, the number of edges increases by 1, the number of vertices increases by 1, and the number of faces remains the same. But this means that V, E plus F does not change. Completing a circuit adds 1 edge, adds 1 face, and keeps the number of vertices the same. So again, V, E plus F does not change. Since we can build any graph using a combination of these 2 moves, and doing so never changes the quantity V, E plus F, the quantity will be the same for all graphs. But notice that our starting graph P2 has V equals 2, E equals 1 and F equals 1, so V minus E plus F equals 2. This argument is essentially a proof by induction. A good exercise would be to rewrite it as a formal induction proof.
Thank you for watching this video.
Don't forget to like, comment, subscribe and share.